Hello and welcome to this video on arrays in Rust. So a special welcome to those who are new to the channel, and if you are new to the channel, make sure you subscribe to the channel and press the bell icon so that you can get notified about upcoming videos on this channel, and we can continue this journey of learning Rust together. So without further ado, let's get started. An array in Rust is much like an array in Python or C. It has a fixed size length, and its signature includes two components. One is the type and another is the length. An array contains homogeneous elements or elements of homogeneous types. Like tuple, unlike tuple, which can contain heterogeneous types, an array cannot contain homogeneous types. That is one of the reasons arrays are very efficient in terms of access and performance. The elements of array are stored in contiguous memory locations. So when you get them by index, the internal pointer arithmetic makes it very efficient to access the elements of array. Not so with tuples. Tuples are very inefficient compared to arrays. So let's see this program and we learn the basic syntax of an array. So for example, access is, by the way, this example has come from Rust by example. So we declare an immutable array access of length 5, which contains integers of 32 bits, 1, 2, 3, 4, 5. So this type annotation you can remove, and Rust Analyzer will do it for you. Now all the elements can be initialized to 0 as well. So ys is an array of length 500 and each element is initialized to 0. So we print the first element of array 0 at index 0 and at index 1. The indexes are 0 based in Rust for arrays. So x0 will print 1, xs will print 2, and so on. Number of lengths of arrays can be, we can get that by calling the len function on the xs. The arrays are located on stack. If you really want a very large array, then you should not allocate this on stack. Instead, you should use the vector, which we will study when we study standard library, because vectors are located on heap, so they can be of very large size, as much as memory allows. The typical size of stack on Linux operating system is 8 MB. On some systems it may be 4 MB, or you can change it by yourself, but in general people don't play with stack size. You can change it, but remember that the default value is not very large, and stack space is very precious because functions also allocate the stack frames on the stack itself. So we can get the size of array memory occupied by array by invoking mem colon colon size of val, and then we pass array as a reference. Next is slices. Now the difference between a slice and array is that the array's length is known at compile time, but a slice is not known at slice's length is not known at compile time. So we take we borrow access and pass it to analyze slice. Now in the analyze slice, you remember its signature is ampersand in the bracket t. Okay, so we have taken the entire array as this slice. So slice 0 will be 1 and slice length will be 5. The signature is like this, 1 space dot dot 4. So it is basically a range. So now it will include the left side, that is index 1, but not the right side. So 1, 2, 3 will be what will be the slice. So now x0 would be, which we are printing, will become 2 here. Okay. Similarly, we can borrow a section of slide. This I have already shown here, an analyze slice. So next is an empty array, which is shown here, and we can assert for equality, and this entire slice is equivalent to the array itself. Now you can, if you want to iterate on array element by element, then the best way is to use the get function. So iterate from 0 to length plus 1, so that the index at most will reach length, which will be the last element plus 1. So this is for the sake of completeness, that we are trying to access beyond boundary. So get will ensure that the operation is safe, and it will return us none. The default value returned by get, if you see here, is an option. So for 0, 1, 2, 3, 4, it will give us a value, but when I becomes 5, it will give us none. So 5 will be too far for us. So index 5 will be too far for us. So let's see this in action. So we run cargo run. So first element of array is 1, second element is 2, number of elements is 5, array occupies 20 bytes, and then first element, as we said, it was 2. So we just change it and see this more carefully. So for example, if you say send it 2, then it will become 3. This 2 should become 3. First element of slice, we run this again. Now first element of slice is 3. The slice has 2 elements. We borrow the entire array slice, then the first element is 0, and then the slice y-axis has 500 elements, and then we print index and the values of the array. So these are the general things we will use to handle arrays. When we deal with arrays, our most common operation would be traversing and doing something with the elements of array. So in general, we will write like this, or we will not even use get. You can actually bypass this thing. You can iterate at an array like this, like so. You can iterate instead like so. Println comma I comma access I. So this will make sure that it is very efficient and we don't go out of bounds. If you go out of bounds, Rust compiler will check and let you know that there is problem. So if you go beyond the array here, then it is not a direct invocation, so Rust compiler does not compute. But if you try this, Rust compiler will contain. So if you know what you are doing, you can invoke like this and it will work nicely. So it detects out of bounds, but in this case it prints correctly. So this is the typical C style invocation of iteration of Rust. So when you do C style iteration of array in Rust, you have to be careful that you don't cross the boundary, otherwise the main thread will panic. So if you want to be on super safe side, you should use get, and that will work out well. But this also works out well because I don't see a problem why this idiom cannot be done. So with this, I will end this video here, and I will see you in the next video, and we will study possibly about structures in the next video, that what is a structure, how we can use them to define our own composite or custom data type. So thanks a lot for watching. You're watching videos of mine motivates me a lot. Please like the video, share as much as you can on social media, make use of the comment box to voice your opinion, and let's interact and let's do good things together. And even if you don't like the video or share or comment, just watching the video is enough, and I'm thankful and grateful to you for watching the video once again. So thanks a lot again. Happy programming.